Okay, good day everyone. My name is Eldar Hadzovic, and today I will present a review of efficient hypervisor architectures for cloud data centers. With me are my colleagues Abduaziz and Yousuf, and our focus is based on the topic of performance, efficiency, security, and emerging trends in virtualization. Before we start with our presentation, we will go over the outline. And first, we'll present the problem statement, research scope, and we need to understand what is a hypervisor and what are the hypervisor types. After this, Abdulaziz will continue with virtualization techniques, CPU, memory, I/O, micro VMs, and lightweight virtualization. And then we will do the performance comparisons. At the end, Yusuf will talk about security consideration, what are the current challenges and future directions of this technology. So let's start. Uh, Virtualization is the backbone of cloud computing, and as cloud workloads grow, hypervisors must provide high performance, low overhead, and strong isolation. While modern applications like serverless and microservices require faster boot time, higher VM density, and efficient resource management. So our study examines how hypervisors achieve these goals. And we can ask one question as a problem statement, which is how can hypervisors deliver high performance, low overhead, and strong isolation as cloud workloads continue to grow over time? And in our research scope, we will compare type 1 and type 2 hypervisors with the new lightweight designs like firecrackers. We analyze CPU, memory, and I/O technologies, performance threats, security implications, and future directions such as AI-driven scheduling and confidential computing. So before we start, as I said, we need to understand what is a hypervisor. And a hypervisor is a virtual machine monitor that abstracts hardware and allows multiple operating systems to run on the same physical machine. Its efficiency directly affects cloud performance, cost, and stability. So this is really important to understand. After that, now we have some hypervisor types. Type 1 hypervisor, as you can see also from the image, runs directly on hardware and delivers the best isolation and performance, while Type 2 run on top of an operating system and introduces overhead. There are two others, micro hypervisors, which minimize the trusted computing base and offer fast startup and high density. And some platforms use hybrid designs, which means they are combining the two techniques, like hypervisor 1 and hypervisor 2. Now that we know what are hypervisors and what types of hypervisors there are, Abdulaziz will continue with virtualization techniques.
Okay, and I'm Abduaziz Al Osman, and yes, I will be continuing from here. And the part that I wanted to mention was the CPU virtualization techniques, as Elder mentioned earlier. And there are two types: one that communicates directly to the hardware, and one that goes through the hypervisor before it communicates to the hardware, and that could lead to slower, let's say, compared to the one that talks directly to the hardware. Okay, and hardware virtualization and extensions eliminate most instructions, trapping overhead. Parallelization reduces emulation, and Hypervisor also uses optimized schedules, core pinning, and NUMA-aware CPU allocation to reduce latency, VM jitters. Okay, and in here, memory visualization techniques. Nested page tables reduce the cost of memory translations. Ballooning helps reclaim unused memory. Page sharing reduces physical memory usage. And also large pages and NUMA awareness improve performance on modern multi-socket. And basically on that what I mean is this slide, this part explains how virtual machines manage memory efficiently. Firstly, it nests the page tables, help the VM translate memory addresses faster, so the system doesn't waste time looking for the right place in memory. And second, a page sharing means if the two VMs have the same data in memory, the hypervisor keeps only one copy instead of two, which saves RAM, as you can see. Finally, ballooning, that technique lets the hypervisor take back unused memory from the VM and give it to another VM that needs it. This prevents memory waste. Okay, and in this slide, IO virtualization techniques, input output virtualization techniques is it shows that things like disk and network access is usually the slowest part of virtualization. To make it faster, we use special drivers like Virtuo. These drivers allow the virtual machine to communicate with the hardware in more direct and efficient way. Because of that, the VM doesn't waste time going through slow emulation all the time, and the input-output operations become much faster. Using parallelizations drivers like VGO, the one that I mentioned earlier, makes disks and network access much faster because the VM can talk to the hardware more efficiently. So that's basically what it means. And yes, and here micro VMs and lightweight virtualizations. And micro VMs are designed for serverless and container scale workloads, like the one like Eldar mentioned. Firecrackers, I personally use them, and it helps with a lot of, let's say, workload. For example, compared to how a normal, let's say, an operating system will communicate with another one, is like it will has to like send earlier. Like there's this thing that they added hypercalls, which actually introduced a whole new era in terms of like this virtualization speed. And the micro VMs, the one that I mentioned, the firecrackers, are designed for serverless and container scale workloads. They remove unnecessary device emulations. Like then, earlier when you need to run or mimic an operating system, and like I mean like and like I don't know if you know these VART managers, that emulators that run operating systems like another operating systems, they usually have to mimic, and then they will create like a, it's not the actual device, so it will create a lot of loads, and then it will call each time. If you make a, let's say if you write something to that operating system, it makes 2 or 3 different calls before it actually gets to the hardware and makes that process. So this macro VMs and lightweight is a nice technique that got introduced, and they remove like unnecessary device emulations, have extreme small memory footprints, and boot almost instantly. Cloud providers use them to run thousands of lightweight functions securely. The lastly I want to talk about this, which is the hypervisor. Consistently delivers the best CPU and memory performance, and there are a couple of hypervisor different like say types: type 1, type 2, type 3, and micro hypervisors and hybrid. So as I told you, type 1 bare metals, and the hosted ones which runs on top of another operating hosting system, and the other one without an operating system, and it's actually used in cloud servers and enterprises and big companies. And the other one is ones we are mostly familiar with, desktop virtualization, software development, and testing environments. And yes, and then there's a hybrid hypervisors, public cloud platforms, and AWS, multi-tenant VMs, like those companies mostly use them. And micro hypervisors, the one that let's say mimic all those big cloud platforms, and like firecrackers, and there is multiple ones, LXD in Linux if you're familiar with it. And yes, and right now I will let my friend continue with security considerations.
Hello, I'm Yousuf, and I'll be talking about the security considerations. The hypervisor sits in a very trusted computing base, so any vulnerability is critical. Target hypercalls, device simulation, and VM escapes, hardware. Protections like IOMMUS and encrypted memory improves isolation. Micro hypervisors reduce privileged code, lowering the attack of surfaces. Could you go to the next? And now we'll be talking about the current challenges, such as Nested virtualizations add multiple layers of overhead. Poor NUMA placements harms many performances. IO contention remains a bottleneck, and hypervisors depend heavily on hardware capabilities. And finally, I will be talking about the virtualization overhead increases data center energy and consumption. Could you go to and here and here we'll be talking about the future directions. Future work will be focusing on the lightweight designs with the small trust computing bases and AI based scheduling, energy efficient resources allocation, and secure integration of VM with container platforms and confidential computing will further isolate guest workloads. Now we'll be talking.
So that's it from us. This is our team. These are the things we did for this project. And before we end the presentation, I would love to mention the conclusions we made from this research. And some of them are that hypervisors remain central to cloud performance, security, and stability. While modern designs use hardware acceleration, paravirtualization, micro VMs, and optimize resource management to reduce overhead, which is the important topic that we need to challenge. Some of the challenges remain in nested virtualization, as we discussed before, as Yusuf mentioned, I/O, NUMA, and energy use, which are the big things we should talk about and we should probably resolve in the future. When we talk about the future will emphasize lightweight architectures and confidential computing while also focusing on AI driven optimization. That's it. Thank you for your time. I hope you learned something and enjoyed our presentation. See you next time.